Hello and welcome to Control F, the NSI Cyber and Tech Center's new podcast that features season-long groupings at the intersection of technology and national security. Our first season of Control F is focused on game-changing technologies that take us through a set of 8 episodes released every other week over the course of 4 months that take a deep dive into the key emerging technologies that are reshaping our world and the ever-evolving tech policy landscape alongside them. During each episode of this season in Control F, we're featuring one or more leading technical experts in a given field, as well as one or more key investors funding the development of these critical technologies. So today, we're going to explore how cloud and edge computing together are changing the way we work with, store, and process data across broad swaths of industry from healthcare to national security. I'm joined by 2 fantastic experts in the field to help unpack how cloud and edge computing work and how they're fundamentally changing the way businesses and individuals operate. Dr. Anton Chuvakin is a security solutions strategy leader at Google Cloud, where he arrived via the Chronicle Security acquisition. Prior to joining Google, Dr. Chuvakin was a research VP and distinguished analyst at Gartner on the Gartner for Technical Professionals team, security and risk management strategies team, where he covered a broad range of security operations and detection and response areas, and is credited with inventing the term EDR for endpoint detection and response. Dr. Chuvakin also worked for some of the earliest log management companies in the early 2000s. Also joining us is Jeremy Hitchcock. He's the co-founder and managing partner of New North Ventures, where he leads investments at the intersection of national security and technology. He's also the co-founder of DIN, an internet infrastructure company that he grew from an open source project at Worcester Polytechnic Institute to a 500-employee enterprise, leading to its $600 million acquisition by Oracle back in 2017. In response to the Mirai botnet attack on DIN, Jeremy co-founded Minimum, an AI Wi-Fi management company and IoT security platform that went public in 2021. With a personal angel portfolio of over 50 companies, Jeremy is recognized for his contributions to innovation and economic development, earning accolades like being a finalist in the 2016 Ernst & Young Entrepreneur of the Year Award. So let's get rolling. Thanks to Dr. Chuvakin and Jeremy for being with us. And Dr. Chuvakin, I'm going to start with you. Help set the stage for our conversation. Could you describe for us, for our audience, what cloud and edge computing means? Talk to us about some of the key architectural components involved in these systems and what makes them so different than traditional computing as we think about it.
So personally, I would limit my answer to cloud because I'm not much in terms of edge. But one thing about the cloud where I would start is that a lot of people throw around like little funny pictures of cloud is just somebody else's computer. And coincidentally, I also run a podcast. And this is one line that's completely banned on our podcast. Cloud is just somebody else's computer. Because for many, many practical reasons, cloud is anything but just somebody else's computer. Now, cloud obviously involves somebody else's computers. That part is true. But it's the just that is the trigger word. Because what people define as cloud native technologies by cloud native foundation or other things that are sort of inconceivable before cloud was created. Now, some of this became very clear to people perhaps 10 years ago, so it's not truly new, but it's very clear that practicing IT or doing IT the way you did it in a data center in the 1990s in the cloud will kind of rob you of many of the advantages. So in that sense, there are specific architectural differences, there are technical differences, there are ways to store data in new ways. But what's also important is there are process and sort of like IT philosophy differences. If you practice, if you do cloud the cloudy way, you're probably not doing annual software updates and waterfall development and slow QA and other things. A lot of stuff is very rapid, very DevOps, or at Google, it would be SRE, site reliability engineering. So cloud really, I shouldn't say breaks, cloud builds a new way for doing things, not only in the form of tech. I'm not logging my relational database to the cloud. I'm using cloud native storage, but also in terms of processes and practices, how teams run things. So to me, that's why at my job, I see a lot of people who do what is known as lift and shift, namely when they replicate their on-premise thinking to the cloud. And then I guess a lot of hilarity happens. And sometimes the results are quite sad because people assume that things will just be better because they're in the cloud, but everything they do is done the old way. Right. So to me, cloud is more of the way of doing things and the tech stack. If you just think of a tech stack, you'll go off.
So Jeremy, what about that? I mean, as an investor in this space, I mean, obviously you're seeing a ton of cloud-based computing. You're seeing that you're investing in the growth of software as a service, SaaS businesses, right? Do you share Dr. Chuvakin's view that cloud is fundamentally a shift in business processes and ways of operating, rather than just a different architecture somewhere else where you've got essentially a out-managed data center that's running a bunch of other people's workloads as well. It's more than that. It's an entirely new way of thinking and a new way of operating. Is that how you see it as well?
Yeah, it is. It's not just a simple, hey, we're going to take a bunch of computers that we used to have in our premise, that we're going to go to another building and we're going to put those same servers there. So as Dr. Chuvakin said, I mean, there's a whole shift. It's not technically, yes, your compute and your storage and your network things are somewhere else, but a lot of the ways in which people are building applications or building tools, that's completely different. And the other things that go along with that, especially in the technology and B2B enterprise world, is that all the dev tools are different. The way that you do QA is different. The way you build is different. And I think that's certainly a very interesting place. And it's not that it's played out, but there's a lot of maturity in those type of cloud stacks, whether it's a Google or Azure, AWS. Those cloud stacks are evolving, and they're actually pretty easy for people to, with very little coding expertise, go into an environment where they can run an application. They can scale from 1 to 1,000. That used to be something very hard. Even 10 years ago when I was doing company things, or 20 years ago, like that used to be really hard. And so now it's pretty easy for you as an application developer to say, hey, this is the data architecture that I want to have. This is the information I want to have. And this is how I want to process it. Or what we're seeing is these things being attached to some sort of vertical application. I'll give a couple examples. So in the first, everybody talks about AI and ChatGPT, and this basically the computer science version is natural language processing. And so it's cool. It's in the last 5 years, we have made a huge amount of progress in terms of the visibility of consumer facing natural language processing. So it's great. You can have something that you can turn words and talk to data on the other end, whether it's relational databases, whether it's unstructured, or whether it's things that are much more complicated. Right. What's going to be awesome, and this is an investing area for us, is how you take that type of architecture and then talk to data that's vertically specific. How do you talk to things that are in the legal domain, the accounting domain, imagery? There's a whole set of applications that companies who are focused on that type of interface may not get the depth in order to necessary to actually do some interesting innovation, interesting products. So that's one category. Yeah. And then the second is, and this is where the edge component comes in, is around computers that talk to things that are in the electromechanical world. And so one of the big examples around that is around operational technology, OT. We certainly talk about IoT. I mean, all these acronyms of how computers are both collecting and controlling things that are in the physical world. Right. And so that is, I think, just in its early infancy. It's actually interesting because a lot of manufacturing companies are going from very simple machines that have some sort of rudimentary controls to completely computerized manufacturing systems. So there's some really cool companies that are doing work in that space, and they're basically going from kind of Web 1.0 to, I don't know, Web 3, Web 4, whatever the heck the numbering is, all in.
Well, probably not 3.
Step. Yeah, so they're trying to go to 4. They're trying to leapfrog.
4. There you go. Yep. Right. So, Dr. Chuvakin, talk to us about how Jeremy's described sort of these two particular categories, right? Sort of this idea of going after vertical spaces where there's a particular, in a particular set of applications you might apply this computing technology to, and then sort of that interface between things doing, physical activities in the real world, whether that's OT in a power plant or IoT in your house. Talk to us about how the cloud either enables or makes those operations easier, or allows things to happen across various domains. I mean, the idea that you've got a bunch of data and a bunch of processing power co-located, where a lot of people are doing it at one time, but of course they're doing their own tenants, right? How does that matter when it comes to being able to put a lot of power to bear on one particular problem set, or bring that capability to bear on things happening in the real world? Or is it just sort of not particularly relevant to those applications?
I think I'm going to start from a bit of a tangent.
Okay.
I think a couple of years ago, so our chief security officer, Phil Venables, wrote this blog about 8 megatrends. We now have the 9 megatrends blog. And it's about kind of why cloud is more secure. But one thing in this blog was really triggering to a lot of people. And that was the cloud is simpler than on-premise. And a lot of people showed up at his door and then eventually at my door to argue about this. And I think that the simplicity of the cloud isn't that the cloud is simple compared to data center, but the fact that it's documented, API driven, and it's kind of all out there. It's abstracted. So to me, this simplicity, despite its triggering nature to a lot of on-prem engineers, is what's at play here. Because if I'm trying to make something work with one cloud or another, or multi-cloud or cloud in a modern on-premise environment, I can be reliant upon the fact that I have an API. I can call an API. It's documented. The results will be predictable. If I apply the recommended security measures, the results would also be secure against the relevant threat model, and things would mostly just work. To me, this is not a certainty in the pre-cloud world. In the pre-cloud world, you may have to kind of think about, well, wait a second, this peculiarity of this particular OS we use would trigger in this particular way, and so we have to mitigate for that. You have a lot of layered cake of IT, from routers to servers to how they're hosted, where they're located. In the cloud, it's kind of a lot of about, here's an API, you read the instructions, you call an API, you get the result. You're almost assured it would work. And to me, this is what makes a lot of this possible. If I'm trying to replicate a lot of modern services like what Jeremy described on premise, you can do that, but there would be an enormous amount of work, and they would also be kind of very luck based. You apply enormous amount of work and you achieve a result in this area, and then you say, we'll just switch it over here, and suddenly you have to do enormous amount of work again. In the cloud, it's a little more straightforward. To me, that's the big part of the power. It's not that we have more servers than you have. It's really not about that. So you can buy servers if you have money, but the fact that the result is tied into a coherent system through APIs, through scaling, through other properties of the cloud is what gets the magic.
Yeah, and so in some ways it's almost not plug and play; it's push and play, right? You've got the capability in the cloud. It's simply getting your data to the cloud, call the right API, and off you go. So Jeremy, talk to us about how cloud has changed the investing landscape, right? One, from a capabilities perspective, that you can now put supercomputing at the fingertips of individuals or developers in a startup or the like, and then also from a investment in cloud infrastructure, investment in cloud capabilities and cloud security, right? No, there's no doubt that that people have argued that the cloud is more secure, right? You can do updates at the push of a button. You don't need to go, find out where all your devices are and push updates to them. It's just you put the update in or reboot the system in the cloud, and off you go. Is there a fundamentally different investment thesis around cloud-based business and cloud-enabled capabilities that's different than it was 5-8 years ago?
It depends on where you're investing in the stack. And so let's say 10, 15 years ago, there's a lot on the tools and a lot of the workflows in terms of how people were developing those type of applications, because the properties of the cloud that were described, it's not as if those things just showed up. It was, well, first off, we needed to have a machine. It would have to have ping and power and a port, like it was there. But when you go from 1 to 10 to 1,000 to 10,000 to hundreds of thousands to large orchestration, the types of things that you're doing at scale really change. And so the first generation of I think interesting B2B companies that were invented around that time, that were investable, were doing those types of things. They were thinking about continuous integration tools. So we have a whole mature ecosystem now of CI/CD dev. We have a whole mechanism of monitoring tools and things that are looking at benchmarking, and not just is the application up in terms of like, I'm going to check to see if it's responsive, but I'm going to make sure that the logic that I'm expecting from that application is actually doing what it's supposed to. So that's all cool. What I think is fascinating now today is people are starting to go deeper in domains, and this notion of software still touching more parts of what we do. And everybody talks about data workloads and data orchestration, AI, ML, like that features somewhere in this conversation. That's where people are bringing different data sets, different workloads, and they're saying, okay, well, how can I get scale? So instead of me looking at 100 different types of companies in a quarter or a year, how can I instead look at 1,000 or 10,000? And I can't do that unless I have computers that help me. But the models that I'm going to use, or the data that I'm going to use, the workflow that I'm going to use is going to be different than somebody else, because I have my specialization. Somebody else has another specialization. So I think today the people who are really pushing at the edge, and I don't mean by edge compute, but people who are doing the innovation work are thinking about data. They're thinking about trust, annotation, attribution, trying to understand, why did the computer recommend this particular thing or say this particular thing? Why did the application show up with this data? We certainly talk about that a lot with self-driving cars and autonomy. is it safe? It's not that the algorithm that is the safest driver is the value. It's the certification process that shows that the process is in fact safe. That's the value. And I think that that's something that more and more organizations are starting to think of. Well, okay, I got this really awesome algorithm, but now I have to either go to a regulator, my customers, a industry consortia, and I have to say that this application is safe, or it's best, or it's high performant compared to some sort of cost quality metric. And that, I think, is where the interesting work is, that those deeper uses of cloud, because then you can get scale and you can start processing a lot more data, and having humans that are augmented by computers. And then maybe we start going to more fuller autonomy application. That's still a little bit off.
Yeah, Dr. Chuvakin, I do want to talk to you about security, but let's talk for a moment about this idea of the deeper use of cloud computing, sort of in this way. Do you agree with the way Jeremy described it, that there's this idea that that there's more space in which to employ cloud capabilities beyond sort of the way we're using them today? And if so, how do you see cloud computing be used sort of down the road? And where's that space for expansion and sort of depth, achieving further depth in this domain?
What I would say is it still, to me, sounds like about the maturity of people who either just think that cloud is just a rented colocation place, like the dramatic lift and shifters who pretty much want to bring the entire IT stack, the entire security stack to the cloud. And then you sort of like, some of them evolve, some of them become half, maybe I would call them cloud tourists. They're kind of like lift and shifters, but they're already living in some cloud realities. And then you go crank it all the way to 11, and you see somebody who was born in 2016, and none of their engineers ever saw anything that predates cloud. Yeah. It just looks like you stepped out of a horse and buggy into kind of not in a spaceship, actually, in a teleporter. A spaceship
even more extreme.
Yeah, even more extreme. It is not spaceship, horse and buggy. Okay, fine, different propulsion, but no, you step from horse and buggy into a teleporter. That's how big the difference is. This is how big the staffing requirements are, how different people are. It's daily jobs are different. So to me, the opportunities are sort of in maybe teaching or educating or growing the maturity from, oh yeah, I have a bunch of servers on-prem. Now they're in Google Cloud. Yeah, no, okay, that's step 1. And we can tell you, we can take you to step 5. But we can also tell you that those people over there, they're kind of at step 11. And in a lot of cases, they are very different. And some of the conversations about how their processes, procedures look like, who they hire, what they do on a daily basis, I see a lot of this reflected in security. I've seen people who say, I have that many systems, I need that many people to monitor them. If I have double the systems, do I need double the number of people to monitor? And everybody in the 1990s mentality in the data center think, well, yeah, obviously, like, 1,000 servers, 2 admins, 2,000 servers, 4 admins. Right. And then it's like, no, sorry, this link can be severed. Yeah. And they're like, what do you mean? That's inherent. Like, no, it's really not. Here's Google. And we do have, like, there's a chart somewhere in one of the slides when we show that the growth of assets and growth of personnel needed to secure the assets, they're not correlated.
Right.
We can grow systems complexity and systems number and not grow the people while maintaining the same level of security. And people are like, no, that's black magic. It's like, no, that's really not. That's just requires many layers of thinking change or process change. So you have to change not from how do I in 3 steps arrive from my 1990s data center to this? Well, that's not a thing. I don't think you have that. I mean, there's a lot of stuff you need to redo. So for example, our team does a lot of client work, where we have to tell people and say, no, go way back, step 10 more steps back to this. And then now let's talk about this. And then we can transform it to something that is reminiscent of a cloud native environment. To me, a lot of magic happens at using cloud as cloud in a more complete way, rather than using cloud as a more modern data center. Like, no, sorry, we should try to evolve more people to that type of mentality, to that type of practices, to that type of, well, everything.
I do worry that I might be a cloud tourist. My first computer was a Tandy TRS-80 color computer with 4K RAM, and I paid for it through college running 10-base cable, where I ran into token rings. So I must be a tourist in this space.
But did you use that tape? Did you use tape storage for this, or did you use a disc?
I did. I had a cassette tape. You're exactly right, an audio cassette tape.
Okay, there you have it. Yeah, sorry.
So. Yeah, I might be one of the cloud tourists. But Jeremy, so look, Dr. Chuvakin is talking about this fundamental shift. You guys have both been talking about this fundamental shift about thinking. So talk to us, and you mentioned AI, right? Talk to us about how this cloud trend intersects with the AI trend. And obviously you need a ton more compute to do AI and do it effectively, the huge data sets, all that jazz, right? But is there a broader sort of interaction we should be talking about between the AI trend and this cloud trend or this cloud and edge trend? And if so, what is that from an investment perspective?
I think they are related, and maybe as a Commodore 64 is my first entrance into the computer
There you
side.
go.
Maybe showing I guess a little of the age of the sets. The notion of a single performant, highly black box AI. I think that's one vision of where AI goes, and cloud has made that happen because of the size of data. And so there's a whole set of questions of what's the source data that you use and where you're finding it. And there's some interesting legal questions around that of how you train those models and what's the source information for that training. But that wasn't possible. Pick your time frame, 3, 5, 10 years ago, like that. There's a reason why we're having so much of this occurring today, is because the scale necessary has really just manifested itself recently. And as Dr. Chuvakin said, that relationship between what you can do with one sysadmin and 1,000 servers, and now it's basically a log function. Now that 2 sysadmins can do 10,000, 3 sysadmins can do 100,000. So when you start going off into the Googles of the world, well, they have big teams, and so they can do much higher units, millions, billions of compute. What's fascinating is that there's also potential to innovate on the other end, which is how do you take highly trained models with highly specific use cases, and whether you're doing things in the scientific domain or you're doing something in the industrial domain. In my world, some of that you're doing that in the classified domain. So those type of workloads and those type of data sets become very interesting to say, how can I take my learnings over here in cloud methodology and then take basically the benefit of tons and tons and tons of compute and then turn that into something smaller and put it on your phone, put it on a computing device that's somewhere different. And so those are the things that I think of that are interesting, because when customers who are saying, hey, I'm going to take my proprietary data center, and I remember this from running traffic at Dyn, there was all those people like, oh, well, I'm just going to take my proprietary data centers and I'm just going to turn them over here, and then magically I'm going to get all the benefits I'm looking for. It's like, that doesn't happen. It's a business process optimization that people have to go through, and it's really reinvention, digital transformation style. So when you're starting to think through, what can I do in that future world? Well, now there's all sorts of possibilities that take place. And it's not as if the efficiencies of cloud show up as it's cheaper. It shows up in, I can do something different. And one of my favorite analogies is the story about radiology. Like many people now 6, 7 years ago said, if you're a radiologist and you're in school, go find another profession, because we're going to eliminate radiology scans. Like all those scans, those are going to be AI enabled. We're going to need any radiologist in 5 years. No one's going to need to read those things. Well, guess what happened? We still have just as many people, but we're doing 10 times the number of scans. Yeah. And so we're able to get more data, which is allowing for better health outcomes. And so these unintended consequences of when you actually bring the cost down to basically free compute, free insights from AI, then you start applying them in a different way, and something that becomes, well, how do I do speculation around energy? And I think about where I'm going to put some sort of discovery assets. Like, that's cool. The flip side is also interesting, and this is a world that we play in, and it plays into security as well, is that when you're trying to look for exploits, it becomes easier and easier to take advantage of things. And I don't know if on-prem kind of old school data centers are more secure, less secure. Cloud has more interconnects. And really, it's a societal fundamental question on essentially around product liability. You could think of it that way, but the cost of breaches, we haven't really figured out as a society how we do that. And insurance companies are having a hard time, and companies are having a hard time thinking of what's the right way. And it's certainly a great business if you're an attacker and you have a country that sanctions that type of activity, of that I could just do it all day. So that there's a lot of fun things.
Imagine if you had one of those. Or
it'd be great.
Or 4, perhaps.
Yeah, it'd be great.
Yeah. Well, so Dr. Chuvakin, talk to us about that. You refer to the famous Phil Venables post, and this question of whether cloud is easier or harder to defend than traditional computing. Obviously, we've heard about the massive hacking threat out there from nation states, criminal actors. There's a lot who say the move to cloud and edge will make things better. And I think the record is mixed on that question. We've seen some catastrophically large breaches involving some clouds that shall remain nameless here, unless you want to mention them. We all know who it is. But we should talk about. Let's talk a little bit about whether cloud and edge or cloud in particular is easier to defend. If so, why? And what about Jeremy's point that now you've got a lot of co-located data information, right? I mean, physically co-located, but also virtually co-located, and a lot more interconnect. Does that add to the vulnerability even as you're gaining something on the security side?
I mean, I think it needs to take some decoupling into the just pure aggregation / eggs in one basket argument versus interconnectedness bucket versus whether you have a lot more sort of resources dedicated to security. Now, I want to start with one, I don't want to follow the practice of people who hear the question and then talk about what they want to talk, but there's one particular obsession in this particular
But bucket. I will.
In this particular case, I will, yes. And then that would be in a helpful manner, hopefully. The point is that a lot of people argue about cloud security, secure cloud. And again, it reminds me of my Gartner years when this debate was really, really hot in around maybe 2014, 15, 16, and it was subsiding. And I bet, well, obviously I'm out of Gartner since 2019. I guess almost nobody calls them anymore and says, hey, is this cloud thing? Is this secure and not? I think that is mostly relegated to the real laggards. I'm thinking the people who really behind, who really didn't get the memo. And I mean the paper memo, of course, not the digital memo, because they're probably not on email yet. But when the argument about is cloud secure is largely closed, it's secure, we still have a lot of breaches, a lot of incidents, a lot of headlines. And people say, so Anton, wait a second, you convinced me that cloud is secure. So what are those headlines? To which my former colleagues at Gartner would say, cloud is secure, but your use of it is not. And that creates a really interesting conundrum, because when you start explaining it to people, again, I had to explain it in my analyst days, people totally get it. Infrastructure, sure, yeah, Google, other cloud providers, they build it really well. Everything is encrypted well, really solid teams are watching it. But then controls are given to the enterprise user or just an end user, and sometimes they forget. Sometimes they do things the on-premise way and let things open. They forgot.
They don't know what they're doing.
That this configuration, they don't know what they're doing. They absolutely, or they assume they know what they're doing based on the 1990s blueprint from the data center. Oh, it's behind 5 firewalls. No, actually, it's in public cloud, and it's within one API access from any place in the world. So that separates the infrastructure, which is more or less no debate anymore, to how people are using it. And to me, that's where things get interesting. To me, cloud still gives us more opportunities to be secure in both of those definitions. But secure use is still occasionally a gap. And in the original Gartner version of that statement, it was like this: 99% of cloud incidents are customers' fault. And no, by the way, it wasn't the cloud provider who said that. It was Gartner. But cloud providers very easily get on board with that. A cloud breach. Yeah, probably customer. Yes, it's customer. Sure. But who has more resources and who knows cloud more? That's the provider. So wait a second. Can we do more to actually make the customer side more secure? And to me, this is the fun part. A lot of our work, a lot of our team's work and other teams at Google work is focused on that aspect. We are pretty much very confident of the infrastructure. But what about the client side? How can we help clients be secure by default? How can we make sure they don't make security sensitive mistakes? How to make sure that their use of cloud is secure no matter what they do? One person tried to use a definition of inevitably secure. It's a little tricky because nothing is secure, full stop, period, against every threat. That's not a thing. But I think inevitably secure is a good way to think about it. No matter what client or the cloud user does, he still retains security of his key or his or their key assets. That to me is a really good vision. And I think that's also something that we subscribe to in most cases when we say, no, yes, we'll enable the customers to do it security.
Yeah. Jeremy, as we think about this idea of security on one side and whether, we put the responsibility in this shared security model on the end user or on the cloud provider, or the cloud provider provides capabilities and the like, one of the things that oftentimes plays a role both in security, but also just on adoption is government and industry standards, government regulation. How does the role of government regulation, industry standards, sort of this question about multi-cloud, hybrid cloud, and this discussion of sovereign clouds. How does all that play into the investment arena? Right? Is it are you as you're looking at cloud and edge computing? Are you in the back of your mind? Is the regulatory environment playing a big role? Is the question of whether the world's going to be divided into sovereign clouds playing a role as you look at investments in this space, Jeremy?
Lots of interesting questions. I think on the technical side of cloud orchestration, I don't think that there's a balkanization that goes on there. I remember from doing some work around ICANN and ITF internet standards, that threat of balkanization of clouds was like that was terrifying, and because it's the benefit of having a universally connected cloud or internet, not to get too confused on metaphors, it is something that we're still unlocking lots of value from. And from the perspective of whether or not security got baked in to the original internet framework, like that's a debate that kind of rages on of well, we really didn't think about that, and how would you have done that? And so we've shimmed in at the lower levels a lot of that thinking in terms of application awareness at a lower level, but really in the end, encryption works really well, key management works really well, identity management works really well. It's just that when you put humans and users in, bad news.
Yeah, I mean, it's all implementation, right? It's all implementation. Yeah,
it's all implementation, and it's all like the problem exists between the keyboard and the chair, the pebcap. Like that's the constant theme. I think we're getting better at it.
Yeah.
Yes. I've seen mix of data in terms of is cloud more secure than whether it's client server or going back further. What you do have is you have these huge aggregations of data. That's something that is very, I think, new, is that you can all of a sudden take all the pie and not just like a sliver, not just a small slice of it. And so that I think
if you're a bad actor.
For bad actors, yeah.
Yeah.
And also the whole notion of wire fraud I'm going to use social engineering. So in this case, like the systems are completely secure. It's the person did not intend to wire the money to the Nigerian prince, like, and even though that's kind of funny to still mention, like that happens today. And the reason why it still happens is because it works. It's just that they're more and more sophisticated. People are taking advantage of cloud to personalize those things. So it's, again, people are thinking about how these things are being used in nefarious ways. What I have confidence over, though, is that notion of inevitable security. I think as time goes on, we're getting better and better at this. And then it's a question of societal of where and how we want to share that risk. Yeah. And you can look at autonomy in terms of driving, and whether it's controversial or not, autonomous driving, that computer help in driving is more safe than a human driver.
Of course, human drivers are looking at their phones, they're drinking, they're whatever, they're mad at their spouse, whatever. I mean, computers don't have any of those problems. They may have other problems, but they don't have those problems.
But tons of problems. But at what point do we say, from a legislative standpoint, this is where I think the policy side is really interesting. This is where the tie into government, I think, is a fascinating question, because it's a question of privacy and ethics and security, and trying to figure out what the right level is. At what point is it going to be illegal to drive a car down the road? And as a person who lives in New Hampshire, live free or die, so I like personal liberties and want to get those balances. But we outlaw drinking and driving, and rightfully so, dangerous. But at some point, there's going to be a comparison between a human driving and autonomy. That ratio is going to be similar to a human driving without the influence of drugs or alcohol, and somebody who is. And at what point is that? Yeah. And same thing on compute. Do we hold individuals liable if they misconfigure things? And I don't think that's the right answer, but I do think that there are those types of things where I forgot to, whatever recent ones in the news that you want to use, it's usually a single point of failure that is a cause. and it's a huge
left my
news story.
left my encryption key on the public internet, like that
Oh,
one.
you know, my dog ate
Right.
my encryption key, and I couldn't push the thing the right way. Like that still works. That's still the
Yeah,
argument
but
that
it's a
goes on.
system design. It points out that the weakness underlying system. I mean, it's almost like a blamey to say it's the user, right?
Yeah. Well, Dr. Chuvakin, what about this? I mean, like, we're seeing a lot of sort of cloud regulation, right? Or internet regulation. We see, in Europe, I mean, we see, DSA, DMA, GDPR, you name it. The Europeans have a law for it, the AI Act now. And you do see the sort of desire by some European countries to sort of divide themselves into these sovereign clouds. I mean, it sounds Germany's less concerned about that. I mean, how worried are you about that in terms of competition and security? I mean, you guys are a global cloud platform, right? Do you worry that this sort of trend of one, coming after some of the bigger players, but also two, trying to, maybe divide the world up into smaller pieces, could be a challenge in this space?
I mean, this does go into an area which usually my, sort of PR and legal oversees,
right.
And I would say that
Stay
the
away.
PR, usually the lawyer cat started falling from the sky. At least that's how I think about it, and I feel like it is. So let me talk about something that's relevant to this, safe from the lawyer cat's point of view, and also kind of interesting. I feel like it's a threat model question. I think that the threat model question is an interesting one, because if you are, there was somebody, and what I mean by this is the following. I met somebody many years ago when I was at Gartner, and he was in Europe, and they were refusing to use a certain security tool set from US because it was cloud back to US cloud. And at the time, this provider only back to a single cloud in the US, and there was no other choice. And it wasn't even the European hosted instances, it was just US backended to US. But it was a really good security provider. And they said, no, we can't use it. This is like, what are you, insane? There's all this regulation. And this person who had the discussion about this is walking in their office, and he sees a lot of gear from a well-known Chinese equipment provider.
Right. No problem. Just plug that in.
And they're like,
it's all good.
Whoa, wait, what are those?
Right.
It's like, oh yeah, they are made by this well-known brand.
I'll say it. ZTE,
for example, them, yes. Right. And it's like, how are they supported? Oh, they are supported by remote support.
Yeah. Oh yeah, just admin logins. Admin logins to your core, core network switch.
To me, the story here is not just like fascinating, fun. We can joke about it, but the fact that, do they have a threat model that indicates that one is okay and one is not okay, or is it random? To me, if you threat model, you may arrive that you have to have absolutely isolated cloud that's physically located in your country with not a single wire sticking out of it going anywhere else. Is it possible? Yes, it's absolutely possible. I've met people who want to keep encryption keys under a particular mountain in Switzerland. They have the vault, they have the mountain, open the vault, stick the key in there, close the vault. That's the process. It probably was driven by some threat model, and for them, it's very logical to want that. But my deep suspicion in my heart, and this is very, very Anton as opposed to like Google in every way, it's like not everybody who opts for that has the threat model down. They may opt for this because their neighbor opted for this, but the neighbor maybe does have the threat model for this, but they don't. If you sell shovels in a random European country, maybe you don't need GovCloud isolated to that country. Maybe you need better security against IP theft. I don't know. People steal your shovel plans. Like, threat model. To me, this basically, to almost every answer in this, I say, do the threat model. Do the threat model. And I sound like a broken record, and it's to me, it's the answer. Sometimes the threat model will lead you to, yes, it must be isolated. Great, go do that. In some other case, you realize, actually, if it's in the US, I don't see why it's bad.
Yeah.
Because wait a second, we're only processing public data. Well, why do we need isolated cloud to process public data? It's the same public data. It's probably from the internet anyway. So to me, that I would just be a broken record. I would broken record it. That's a verb now about the threat model.
Yeah. Well, I think it's an interesting way to think about it, and I think you make a really good point that depending on how you view the world and how you view the threats you face, assuming you're even doing that, it's not just instinct or like you said, what your neighbor does. that could significantly change things. So, Jeremy, as we wrap up, I know we're short on time, but I do want to get your take, since you're a national security and technology focused investor. How do you think, sort of, you mentioned the intelligence community and the government's use of AI and cloud capabilities. How do you see cloud adoption going in the government, particularly in the intelligence community and the national security community? Is this going to be a success? We've seen, obviously, C2S, Google has their high cloud, Azure has theirs version of it as well. How is it going? Is it going to work? And is the government going to figure its way out? Obviously, we had this debacle of a DoD procurement that ultimately has now ended up in God knows what. Maybe something about in 10 years from now. Can the government think its way out of this box? And if so, what's it going to look like?
I mean, they will figure something out, because they're doing it every day. I think that the threat model, using that analogy, the threat model for them is very different in terms of how they think of insider threat, foreign actors. I mean, it's a completely different world. The downside of what they have is they have a legacy of, I mean, they started with the internet, so they had computers, but they have obviously compartmentalization. There's a number of high side clouds, and that, I think, is working really well. But the other cases, a lot of the needs for how they're thinking about cloud don't lend themselves, because they're doing these vertically integrated types of efforts. And so in some ways they don't get the benefits of wanting cloud, but they still need the compute, and they still have huge data sets in some ways, but they need to find this one little thing. So it's intellectually, and as a technologist, I have some of the richest problems are in that space, in terms of how you, and probably one of the ones that's easy to use as example is imagery. So there are exquisite government-owned systems that produce imagery, and there's stuff that's off the shelf. And normally, when you think about multiple sets of data and being able to integrate them in a workflow, to add data here and add data there, like that in an enterprise setting can be complicated, because you can do that with microservices we talked about, and like APIs, and that's super easy. Right. Oh, we are still trying to figure out, I'd say, in government land, like where does that go 100%? Yeah. And a lot of really cool efforts that are going on. I think it's still early days there. One thing I would say, though, is the people who are thinking around how to make those implementation choices, though, are really trying to think about it from that long-term perspective, because, and this goes to the regulatory side as well, because one of the things that I've admired most is the types of decisions that data and intelligence, as an example, is used to inform policymakers. That has to be right. And certainly there are errors. There's errors in anything of what humans do, but the level of attribution, and so the level of trying to get that stuff right for a long term, because one of the things about regulations is that we can experiment a little bit more, and some of the ones I worry about they get put in place, and then we have to go build technology around those things, and we're not keeping up in terms of regulation and policy and how we think about it societally. But the notion of trying to get that right in the government context, I think, is one that, when I've met people who are doing that type of work, they're definitely thinking about the challenges that they're facing, and I'm pretty excited about where they're going.
Awesome. Well, Dr. Chuvakin, we started with you. You get the last word. Talk to us about how you see government adoption, particularly in the national security domain of cloud edge capabilities. Are they going to make it happen? Jeremy seems optimistic. There's an opportunity here. I don't think anybody disagrees the tremendous value that can be offered. What do you think?
I mean, it's almost like a very safe question, right?
I didn't mean it to be. I was not trying to make it safe.
No, it's.
But, right.
I think it's a safe question in the sense that it's. I don't think anybody would say, no. The real future is more like back to the mainframe, and it's like the 70s. Forget the 90s. I don't think so.
People in government who think that way. I mean, there are people who believe so strong in compartmentation. They are very stressed out about the cloud. I mean, it's freaking them out.
Banks that are still mainframes, though, and some of the people from some of the security stuff, the reason why they didn't get affected was because they're mainframes. I mean, there's still plenty of laggards in the corporate world.
Sure, but even in that, exactly right. I mean, I think that it's not so much that does anybody think it's the future? I think we all agree that there are people for whom it's the present. Yes, no debate here. But do they, wake up and think, oh yeah, the future is probably doing what we've been doing since the 70s? Like, probably in a tiny niche. But even there, it's a kind of a matter of debate. Like, we had some some of our leaders from, like, broadly speaking, the security team have written about how we also think that the bringing every cloud to higher security requirements is a better route than just building a separate cloud in the corner and calling it GovCloud. Like, I'm looking at what Jeanette Manfra has written, I think, as it turns out, 3 years ago. Oh my God, that's been time. She wrote a piece that basically highlighted the fact that GovCloud is probably not an answer. You need to bring all cloud to that type of security standard. And that's largely our approach. We believe it's ultimately better and more secure for everybody, both governments and their stakeholders.
Well, there you have it. All right, that's a wrap. Thanks to both Dr. Anton Chuvakin and from Google Cloud and Jeremy Hitchcock from New North Ventures for joining us today. Thanks to Keelan Wolf, Claude Jennings, and the entire NSI CTC staff in helping us produce today's episode. The Control F podcast, including our Game Changing Technologies series, is also on YouTube, so you can see our smiling faces. So be sure to check out NSI's YouTube page for a video of today's episode. And make sure to join us for our next episode in just 2 short weeks, where we'll explore how secure by design and resilience by design principles are essential to creating systems that are not only secure from cyber threats, but also resilient enough to recover from unexpected disruptions. And as always, if you like what you heard or saw, be sure to rate, review, and subscribe. Thanks, everybody. See you in 2 weeks.